In this lecture, we will start with the algorithm design techniques. But what exactly the algorithm design technique means? What is meant by algorithm? In general, algorithm means every program consisting of two things. One is data structure and algorithm. So algo is a step-by-step method of solving a problem. So in the process of solving problem, the data structures will help us in maintaining the data for ready usage by the program. So that is what the data structure is. And algorithm means the method or the procedure that we use for solving a problem. Whenever you combine this data structure and algorithm, then it is said to be a program. So data structures, so we have seen several data structures so far, like single linked list, that is static data structures and dynamic data structures, and tree data structures, that is which are said to be non-linear data structures. So all these things we have seen. These data structures usually will reside in the main memory. Now algorithm is one that which will solve the problem. Actually, we are not addressing the problem here. We are addressing the data structures so far. But actually, if any problem has been given, how you will solve that particular problem? That is what is called algorithm. So here, algorithm design methods in sense, in what way you will solve the problem will come under the algorithm design technique. So whenever a problem is given, when when a problem is given, usually the problem will be of problem is of optimization problem or to achieve something based on some conditions. It is just like you have been given a bike or something. You have been given a bike or two-wheeler, and you need to reach a particular destination, provided there are several paths to reach the destination. And I am going to put a condition that you should reach the destination as soon as possible. However, you should not cross more than 100 kilometers per hour, and you should uh, you should not make any horn, or you should not. That means um, you may use any path of your choice, but you have to make the condition. You have to follow the condition that you should not cross 100 kilometers per hour, and you should not take a lift from anyone. So like that, I will keep some conditions. Whenever I keep conditions, based on these conditions, I need to achieve the solution. I need to achieve the problem objective that I need to reach the destination as soon as possible compared to any other person. That means you are supposed to here. This is you are supposed to devise a procedure in such a way that by following these conditions, you should achieve the objective. This is a problem which is called the achieving something problem. While coming to the optimization problem means I am going to the same problem previously what I told. If I convert in such a way that in different way that I need to reach the destination in the shortest path. That means there exist several paths, around 10 to 15 paths are available to reach the destination. But I have to opt a path that is a very shortest path to reach the destination. That means here optimization problem will come into the picture. This optimization may be a maximization. This optimization may be an maximization problem or minimization problem. So optimization may be a maximization or minimization problem subject to given conditions. These conditions may be, or we can say these conditions are of local conditions or global conditions or both. That means there may be a local condition or maybe a global condition. So here, whenever I say local condition, I need to reach to a destination, provided I have been given a two-wheeler. I need to reach the destination in the shortest path. This is an optimization problem. Here, minimization of the distance. Here, local condition is whenever you find a 60 feet road, you should not cross 50 kilometers per hour. Whenever you have 100 meters road, then you can go, you should not cross 100 meters, 100 meters, sorry, 100 kilometers per hour. This is the condition I have placed. Here, two conditions, local conditions and global conditions. So whenever you're going on road, if you find a local gully or local road, then you should not cross this much speed. And whenever you find a main road, you should not cross this much speed. So that means you are supposed to follow both the things. And one more thing is, we can say this is the speed restriction I have placed. And also, if I place the distance restriction, then I have to follow the speed restriction at the same time minimizing the distance restriction. These are the two restrictions I need to place, or I need to follow to achieve the objective. So these are the ways in which the problem has to be solved by considering the conditions wherever required. These are the conditions are said to be these are the conditions are said to be local conditions or global conditions. Sometimes both need to be followed or both need to be achieved to reach the objective. And that objective may be an optimization problem, or the function that is going to be minimized or maximized is said to be the objective function. So which is also said to be objective function. So this objective function need to be satisfied by achieving the subject to the conditions, the given condition. You might have studied this kind of concepts in the operations behavior or the optimization kind of things, etc. So in the process of solving the problem, algorithm has a perfect definition. That means the algorithm should have a zero or more inputs and should have one or more output, and the algorithm should terminate in a finite number of steps, and the algorithm should be very simple and easy to compute, and should be terminated within the finite number of steps. That means uncountable number of steps it should not take, but it should take within the finite. The algorithm should terminate within the finite number of steps by providing the proper output. This is what the properties of algorithm. So in the solving of this solving of algorithms, sometimes you may be having the type of algorithms as deterministic algorithms, and another is non-deterministic algorithms. So here deterministic algorithms are one that will that will be executed and completed within the finite time. Where in case of non-deterministic, the name is telling you that it is non-determinism, whether you may get or may not get the output. So here you may solve the maximization problem, or you may solve the objective function, or may not solve the objective function. So this is what the non-deterministic algorithms. So far, whatever the algorithms we have seen, all are the deterministic algorithms. That means they are going to complete or they are going to terminate within the finite number of steps. While coming to the non-deterministic algorithms, they are very difficult to solve. At the same time, they are not difficult to solve, but they are you cannot achieve the perfect solution. The optimal solution cannot be reached with the non-deterministic algorithms. So such non-deterministic algorithms will be solved via approximation algorithms. Approximation algorithms. What are these approximation algorithms? That means here in deterministic algorithms, you will achieve exact solution. Where in case of non-deterministic algorithms, you cannot achieve exact solution, but you can achieve near optimal solution. Near optimal solution. What is near optimal solution? The optimal solution may be, say for example, by solving a problem, the optimal solution may be 3 or 4, but you never reach 3 or 4 in case of non-deterministic algorithms. You may reach near optimal, maybe 3.6, 3.7, thereby the algorithm terminates. Okay, so whatever is the final value you will get, which is called a near optimal solution. So that means whenever any algorithm or whenever any problem solving consisting of a deterministic algorithm, then whatever the things you are going to implement will give you an exact solution. Some algorithms cannot solve within the by using the deterministic algorithms, which are all we can say these are all of kind of stochastic or random related algorithms. You don't know how this particular input will be taken, how the things will be processed. So thereby some non-determinism will come into the picture. Such non-deterministic algorithms cannot be solved and cannot give you a perfect solution. So for that, to solve that non-deterministic problems, we use approximation algorithms. What these approximation algorithms will do is they will give us the near optimal solution. So best example of this non-deterministic algorithms, and where you will go for providing of the approximation algorithms. The best example of the approximation algorithms are nature inspired computing algorithms. Or we can say genetic algorithms. Or genetic algorithms. These are the various algorithms which are used for solving the non-deterministic problems. But so far, whatever the problems we have seen are the deterministic algorithms. While coming to the graph algorithm, in graph we have taken only 7 vertices or 8 vertices, maybe 10 vertices. But if the graph size is too large, then sometimes we may not achieve the problem solving in the deterministic time. So they will also fall under the non-deterministic conditions. So the traveling salesperson's problem, graph coloring problem, these are the various problems which are of type non-deterministic in nature. So why I'm telling all these things, these are the categories of algorithms. So in this algorithm design techniques, so far we have seen and examined a number of data structures and algorithms to manipulate them. We have seen examples like binary search, depth first search traversal, merge sort, quick sort, which will fall under the divide and conquer technique. That means you are going to divide the array and you will go for sorting. And in case of binary search, whenever you compare with the root, if the element or key is less than the root, you will go and traverse at the left side, and half of the tree will be ignored for searching. So that means here it is a divide and conquer method. And we have seen greedy algorithms. I have not discussed what is meant by greedy algorithm and all. But whatever the algorithms we have seen, like Prim's algorithm, Kruskal algorithm, these algorithms will fall under the greedy category. Okay. So now we'll examine a number of strategies which may be used in designing of algorithms. Based upon the problem situation, based upon the problem objective, we are supposed to devise the algorithm solution by using some systematic procedure. That procedure is said to be the strategy, we can say. That strategy may fall under the following following techniques. One technique is greedy algorithms. Another is divide and conquer algorithms. First one is greedy algorithms. Second one is divide and conquer algorithms. Next one is dynamic programming. Another is backtracking algorithms. And another is stochastic algorithms. And here I would like to mention one more thing along with this one is branch and bound technique. Okay. Branch and bound technique. So these are the various algorithms that we can use for solving a problem. It is basically based on the type of problem that we are supposed to solve. There are other techniques not covered in this course, such as evolutionary algorithms, combinatorial algorithms, distributed algorithms, gradient methods. Here I have told you approximation algorithms, which are approximation algorithms are there, which are used to solve the non-deterministic algorithms. This nature-inspired computing, genetic algorithms, these algorithms will fall under the evolutionary algorithms. Okay. Here we are going to use some nature-inspired computing techniques to evolve the solution. Thereby, finally, ending of the algorithm will reach a near optimal solution. That is what the basic idea of the evolutionary algorithm. Here, combinatorial algorithms, distributed algorithms, gradient methods are somewhat specialized algorithms, where in the combinatorial you will use the combinations, permutation and combinations related strategy to solve the algorithm, to solve the problem. Where in case of distributed algorithms, here whatever the algorithm we are solving or computing are centralized. That means we are going to write a single centralized program and solving the particular situation. But in case of distributed algorithms, usually these are not centralized algorithms; these are decentralized algorithms. But finally, the output or the final output will be received by the initiator. It is just like distributed computing. Like for example, I have given an assignment of 3 to 4 questions, and I have made a group of 4 members. Now, the task of completing assignment is given to these 4 members. That is a batch. Now, the team may be having a team leader and team members. Now, what the team leader will do is he will divide the task of writing the or solving the questions. Since there are 4 questions in the assignment, so one question he may take, another 3 questions may be distributed. So another 3 members of the group will solve themselves and will be in communication with other people that how far they have done and what the material they referred. Okay, this kind of things. Finally, they will do their task and submit the work back to the team leader. Now, team leader's task is to combine all the things and finally present the result. This is the type of computation or solution which will fall under the distributed algorithms. Where in case of gradient methods, these are also some specialized methods. So, by and large, whatever the greedy algorithm, divide and conquer, dynamic programming, backtracking, stochastic method, branch and bound, all these are the centralized algorithms. However, we can also develop a parallel algorithm for this, for the centralized one. Parallel algorithms means the same program will work parallelly on different processors. That are called parallel algorithms. Usually, centralized algorithm means at one place in one system only, all these algorithms can execute. These are the centralized algorithms. So in this, as part of our course, we are going to see the introduction to algorithms and significance, introduction to backtracking algorithms, branch and bound, introduction to greedy algorithms, problems on greedy algorithm, 0-1 knapsack problem, introduction to dynamic programming, problems on dynamic programming. Here, it focuses on the branch and bound, backtracking, greedy, and dynamic programming. And the remaining other techniques were not discussed in our syllabus. However, I will try to cover as many examples as possible. So anyhow, the divide and conquer technique we have covered. The example of divide and conquer methods are the merge sort, quick sort, binary search, depth first search traversal. All these techniques are all fall under the divide and conquer method. So remaining leftover are backtracking, branch and bound, greedy, and dynamic programming. These four categories we are going to see in our course. Stochastic means some randomness will be there. This one also we are not seeing in our course. We are not discussing in our course. I hope by this time you come to know what is the algorithm, importance of algorithm, and algorithm design, and how many categories of algorithms are there, and how these algorithms will be solved, and based upon the providing the solution to the problem, we have two methods: deterministic algorithms and non-deterministic algorithms, and how these algorithms can be will be modeled and executed. So I am not going to I am not going to discuss this non-deterministic algorithms, but however I am providing the deterministic algorithms, in which first what I will do is, as per our syllabus, here backtracking and branch and bound is there. I will start first greedy algorithm, because the greedy algorithms are the initial algorithms. Anyhow, the algorithms related to the greedy method have already been discussed by us. So first I will start with the greedy algorithm.